Hello and welcome. Welcome back to the channel. Today we are diving into linked list in Python, which is a key data structure that is crucial for technical interviews, coding exams, and efficient data manipulation while you do coding. By the end of this video, you will know how linked lists work, why they are useful, and even how to implement and manipulate using Python linked lists. Let's jump into the definition. What is linked list? So a linked list is a collection of nodes where each node has some data and a pointer. The pointer which is to link to the next node after the current node. Unlike arrays that store elements continuously in the memory location, linked lists allocate memory dynamically and link nodes together through the pointer. And let's compare with the arrays in Python to linked lists. What are the main differences from arrays versus linked list? Linked lists are dynamic in size, whereas arrays are fixed size. Linked lists allocate memory dynamically, whereas arrays require contiguous memory. And second, insertion and deletion in a linked list can be done with less time complexity, which is time complexity O of 1 just by updating the pointer, but in arrays it might need shifting also. And then third, accessing a specific index in a linked list requires O of n time complexity because it has to traverse through all the elements until it reaches the required element based on index or value. But in arrays, the accessing time complexity is O of 1 because we access direct. That's all about differences from arrays. Let's see one interview question on linked list until now. Why you choose a linked list over array? So this is a basic question. You should be ready with the answer. The reason being dynamic size of linked list and efficient add delete operations with O of 1 complexity without shifting elements. So that is why generally we prefer linked lists. Let's see the main different kinds of linked lists, types of linked lists. there are basically three common types. One is singly linked list. Number two, doubly linked list. Number three, and last one, circular linked list. So the last type, circular linked list. Let's see each type definition. In singly linked list, each node points to the next node. So node will have data and pointer pointing to next node. Whereas in doubly linked list, nodes have both next and previous. So previous, data, next. So the previous holds the previous node's address. The next contains the next node's address. And let's see what is circular linked list. This is also same, but only the difference is the last node, which is called as tail node, links back to the head, which is also a singly linked list, but it holds the head address from the last node. So let's see the pros and cons of each of these types. The doubly linked lists support bidirectional traversal. Circular lists are useful for cyclic data structures, and single linked lists are for one-way traversal. So based on the type of the linked list, the code complexity and the time to traverse through increases or decreases. Let's see through examples how these types are utilized in our problem solution. First, let's take a simple example of node traversal. A singly linked list node in Python typically can be defined as a class like class node, with a init method, self, and data as parameters. Again, we will assign self.data with the data passed, and self.next is none initially. So this is the class definition for the node. Let's write the class for traversing. So to traverse, start at the head and follow next until you hit the none, because the last element holds none as pointer. So let me write a method first for this traversing. Definition: traverse, we have to only pick the head, current equal to head, first in first out case, and let's write a while loop. Current, while current, what we are going to do? Traversing. So print current dot data with a pointer indicating arrow mark. So that's how we print head value. So current dot data becomes head dot data pointing to next value. So now we have to move to next. So current becomes current dot next. We have printed the first head and then the head will be moved to next element. Likewise, it traverses through all elements until it reaches the last element. At the end, print none. So this is the traversal method we can implement within any class for singly linked list. Let's see one exam question. How do you traverse a singly linked list in Python? Let's prepare the answer for your next interview. What is the traversing way in a singly linked list? How do we do? We initialize a pointer to head because we need to fetch the head first and then loop until it is not null and process data and move next within the loop. Answer must be initialize the pointer to the head and loop while or loop until it reaches the null. Within this loop, what we have to do? Print, process data and move the pointer to next. So these are the steps to traverse singly linked list. Whatever you have written in the above program, you're just giving a step-by-step algorithm as our answer. Let's go to another problem solution for single linked list. The question might be like, find a minimum value or find maximum value from a linked list. Let's write a program to find min max of linked list. Let's start with definition. Find min or find lowest. We will pass head, min value equal to head dot data. We will initialize with the head and current becomes head dot next because we need to compare. So current becomes head dot next while current if current dot data less than min, what we will be doing, we will assign this to min. Current dot data becomes min and we will even check if current dot data greater than max, then what we will do, max equal to current dot data So the max becomes current value. And then we need to move the head to move the current to the next element before going to next step in the while loop. So it traverses through all the element and checks current data with minimum. If it is less than minimum, it goes the minimum value. If it is greater than maximum, it goes to the maximum value and the pointer will be moving to next until the current becomes none. So here we have to give max also head dot data. So this is how we'll be fetching min and max. So after doing all the steps, well, we have to print, otherwise return min comma max. So that is how single linked list implementation for find lowest and the highest. We can say min max, or even we can write two methods. One is to find minimum, one is to find maximum based on our requirement. Now let's see another question on the same. How do you find the minimum value in linked list? Then you have to explain this in algorithmic way, saying traverse the list, compare each data with the current minimum, update as necessary. For the same, max also compare with max and update the max as necessary. Finally return min and max. Let's see one more example. We'll discuss couple more examples. We have seen how to retrieve values, how to return min max. Now the third question or third example, delete node from linked list. So let's definition delete node. We have to pass head, we have to pass target. So there inside if head equal to target that is to be removed, then we have to return head dot next. If it is achieved, we will simply return it, or what we have to do, we have to assign current node as head node, and we have to traverse while current dot next and current dot next not equal to target, assign current equal to current dot next. So what it does, it checks current dot next is not null and current dot not next, sorry, current dot next not equal to target. So if both the conditions fail, if it is not null and then if it is not target, it assigns current dot next as current node and it returns head next. So that is how deletion is implemented. And last, after doing it, You can execute and see what actually happens with this particular code implementation. If current dot next means if it exists, then current dot next equal to dot next. So what it is doing, it moves one step forward and finally return. Head means, so current dot next will have the value which we have sent as target to delete. So it will have that current dot next. So it will assign current dot next with the next element of the target deletion, current dot next, which is simply removing the link to the target, which is nothing but deletion. You can execute the program and see how it works for the deletion of node. So the question that is expected, what are all the steps to ensure safe deletion in linked lists? Locate previous node is the first step. So fourth question is, what are all the steps to ensure safe deletion? Locate previous node of target and adjust its adjust the previous nodes next to skip the target. So these are the important points for safe deletion. In addition to this, there is no dangling pointers. Update head if needed. Means if the element that is to be removed is head, then we have to update head as well. So that's all about deletion of node from linked list. Let's see the last example in this section for linked list, which is inserting the node. So insert is similar to deletion, but we have to be very careful while adjusting the pointers, because the placeholder where we have to insert the node, the previous nodes next becomes the new node that we are inserting, and the new nodes next becomes the previous nodes next. Let's implement it programmatically. Insert at, we have to pass head, we have to pass new node, we have to pass at which position to insert. If position equal to 1, first position means we just have to new node dot next equal to head and return new node. So what we simply can do, if it is a first position means simply place next of the new node as head. That's all. That will take care of inserting new node at the first position. If not, it is first position to insert apart from 1. Let's do the steps current node equal to head Let's write a for loop. In range post minus 2 if current is none. Then what I have to do? Break. If it is not none, then current equal to current dot next and new node dot next equal to current dot next. Current node dot next equal to new node. We are just doing the new nodes value as previous nodes next, and current new nodes next becomes the previous nodes next. So that's why I have implemented. After this, just return the head. So that's all about insertion. If you have any doubts on this particular implementation for insert, delete and addition into the linked list, you may post comments. I'm happy to help you. So that's all about today's video. Before closing the video, just we'll go through the time complexity of linked list, which is traversal, find, insert, delete, all take O of n time. Worst case, random access is O of 1 in arrays but O of n in linked list. So binary search isn't feasible on linked list. And the key pointers to remember about linked list is they provide dynamic sizing and efficient insertion, deletions. They require sequential access, so some operations can be slower because of time complexity for traversal through nodes. Understand when to choose singly, doubly, and circular lists based on traversal needs. Mastering traversal, insertion, deletion, and core exam questions is essential. So let's wrap today's video for linked list in Python. Like, subscribe, and drop a comment on what data structures that you are like to understand more further in the linked list. You may comment. I'm happy to help. So that's all for today. Thank you for watching.